Okay, so quickly we are going to work on those problems. The first question here is find the HCF of 12 and 18. And the set also said find the HCF of 14 and 49. And then here we are going to look at find the LCM of 6 and 8 and find the LCM of 7 and 3. Now actually mastery of HCF and LCM is very important. Because many times when you solve higher level mathematics, you will be required to actually do this. One or two, in fact, in very many occasions, you'll be required to find HCF, LCM, because you use it to simplify mathematical problems. Alright, so you need to know this very well. I'm using smaller numbers here, I mean small numbers. But of course, if it has to do with bigger numbers, the same strategy still applies. Alright, so let's now move to the solution for those problems. Okay, first of all, they said find the HCF of 12 and 18. So I promised you a different approach for doing this. Okay, if you want to start looking at the factors of 12 and 18, the prime factors of 12 and 18, it could be so much. Alright, so what we are going to do is to do this 12 and then we have 18. So we are looking for the HCF of these two numbers, 12 and 18. Now, since we are looking for HCF, what we are going to do is we are going to look for numbers that will divide through each of those equally without remainder. Okay, we are going to look for two numbers. Not two numbers. Any number that can divide through 12 and divide through 18 without remainder. So it's traditional to always start from the small numbers. Okay, let's start from 2. Okay, 2 into 12 will go 6 times. Okay, 2 into 12, that's 12 divided by 2, 6. 18 divided by 2 is going to go 9 times. Alright, so that's done. So we also look at these two numbers. Can they be divided by 2 without remainder? 6 can, but 9 cannot. Since 6 can and 9 cannot, we don't use 2 to divide through. What we use is going to be 3, because 3 can be divided, 6 can be divided by 3 without remainder, and 9 can be divided by 6 by 3 without remainder. So that would mean that we have 6 divided by 3 to get 2, right? And 9 divided by 3 to get 3. Okay, so that's that. Now let's also look at those two numbers, 2 and 3. Do we have any number that can go through both of them without a remainder? The only number that we would think of is 1. Okay, 1 is inconsequential in this case because anything multiplied by 1 remains that value, right? So this is, since we don't have any number that can go through both of them, that can divide through both of them without a remainder. So this is where we stop. We don't do anything further. So at this point, we can comfortably say that our HCF is 2 times 3, which is equal to 6. Okay, 2 times those 3. Okay, that gives us our highest common factor of 12 and 18. Okay, having gotten that, let's also look at how we get the HCF of HCF. Please, if you did not really get this, all you need to do is to replay the video and you are going to get it. Okay, let's get the HCF of 14 and 49. HCF of 14 and 49. Now we are supposed to start with a number that can divide through 14 and 49 without a remainder. Let's look at that. Most times the numbers should always be prime numbers, of course. So let's start with 2. If we take 2 through, 2 can divide. 14 can be divided by 2 and you get 7, but 49 cannot be divided by 2, so we cannot go with 2. 3 is also not a factor of 14, neither is it a factor of 49. So what number can we go? Is it 5? Can 5 work? So 14 divided by 5 does not work. 5 is not a factor of 14. Okay, So that means it cannot divide it without a remainder. Same thing goes to 49. Now, so the next prime number we can look at is 7. Okay, 14 divided by 7 will actually give us what? 2. You see that will give us 2. And 49 divided by 7 will give us 7. Now, at this point, is there any number again that can divide 2 and divide 7 without a remainder? The answer is no. There is no other number. So what this means for us is that the HCF of 14 and 49 is going to be 7. Just this 7. Alright, so that's how we handle HCF and LCM. Okay, without having to stress ourselves much. Alright, so having said that, let's move over to how we get LCM. Okay, so you want to get LCM. These are the numbers we have, 6 and 8. Okay, so we want to get the LCM of 6 and 8. We use the same placement just like we did in HCF as you have just seen. Okay, what we do is we look for a number that we keep dividing this, okay, to the list. Okay, we start with 2. Okay, so starting with 2 now, 6 divided by 2 gives us 3. 8 divided by 2 gives us 4. Okay, once that is done, we look for another number. It does not matter, provided the number can divide any of the number, we use it. Okay, so 3, 2 cannot work now. 2 can still work. 2 can still work. So 2 goes into 3 divided by 2 cannot. So we still write our 3 here. 4 divided by 2 can. So that we have 2, right? Good. So can we go again with 2? Yes, we can go with 2. So you see, 3 divided by 2 cannot. So we still write our 3 here. 2 divided by 2, we have 1. Okay, so once that is done now, what number can we use to divide this now? So we have 3. 3 can go. 3 divided by 3 is 1. We bring down this one. So this marks the end of our division. Okay, so this marks the end of our division. So what do we now do to get the LCM? The LCM here is going to be equal to this times this times this times this. So we have 2 times 2 times 2 times 3. So 2 times 2 times 2 is 8 times 3. 8 times 3 is 24. Okay, so that's how basically all those things work. Okay, so it's as simple as that. Okay, so if we want to look for the LCM of 7 and 3, the LCM of 7 and 3, let's look for the LCM of 7 and 3. 7 here and 3 here. Okay, so we look for a number. Now, if the numbers were up to 3, we would still add 1. If, let's say we had 4, okay, or so, yes, we just add it and repeat the same process to include this. Okay, but since we don't have any other number, let's work with what we have. So we look for a number that can divide any of them. So 2 cannot divide any of them, but 3 can. 3 into 7 will not go, so we are still left with 7. And 3 goes into 3, we have 1, right? So you see that. Then we now look for another number that can divide either any of them, which is 7. 7 divided by 7 here will give us 1. We bring down this one. So we are done here. So the LCM of 7 and 3 is just going to be a multiple of 3 and 7, which is, that's this 3 and this 7, which gives us what? 21. So if you follow this, you can actually find the solution. You can find LCM and HCF of any number anywhere in the world. Thank you.